Let's start. Welcome. Hopefully everybody can in the middle. This talk is about Elasticsearch and Ruby. You'll learn how to use Elasticsearch in Ruby for your applications and stuff like that, but it's more like a meta talk. It's about my experiences I gained when I was doing the gem for Elasticsearch called Tire. My name is Karel Minarik. You can learn everything at this website. I work for Elasticsearch, which is a company behind the open source product right now. Elasticsearch, in a nutshell, is a Lucene-based search engine. It's built on top of that and brings a lot of things on top of raw Lucene. Its main usage is for searching and analyzing big data, because it's a distributed search engine and it has built-in scalability. What's really good for languages like Ruby or Python is that it's very friendly to them, because it has a RESTful HTTP API and it has a domain-specific language expressed in JSON. Both of those are things we are used to. We use it every day and we use it in our architectures. So it's it fits very well in web-based workflows or environments. But okay, this is a Ruby and Python conference, so what's in it for Rubies? The library I started something like 2 years ago in this gist. It's basically 200 lines of code. It wraps the connection to Elasticsearch, it wraps the search results, and brings a fairly nice DSL. The resulting library, which came out of it, right now is being watched or starred by nearly 1,000 people, was featured on Railscast, so it grew a lot. So let's have a review of Deadgrowth. First of all, I had it very easy, because given Elasticsearch has a RESTful API and talks with JSON, the only thing I had to do was to wrap HTTP and JSON, and that's it. In fact, you can pass a piece of code which wraps multi-JSON and Faraday and pass it as Elasticsearch library, because it really is. Sending hashes over HTTP in Ruby is not hard, so you can work with Elasticsearch in that manner. The problem is that the query DSL is very vast, and this is just an example query. It's not something over-complicated. It does a range query for a certain time frame. It does a Boolean query, matches on tags, Ruby and Python, and it matches title property of your documents for a token conference. But you can see it's rather long. And you can also see how that syntax naturally lends itself to using blocks in Ruby. So that's what I did. It's reasonably more readable, reasonably more expressive, to use blocks to express these nested structures. So this is not a same query. It's from Tire's README. But you can see that it's much more convenient and more pleasant to work with that. And that's your job as a library designer. Like, the ultimate goal is single one, make it more easy for people to express their intents. There are other good things about blocks being used for DSL like that. The immediate outcome you get out of it is that you can save the block as a lambda to a variable. And you can later reuse that structure. So you can mix and match different queries and reuse the logic you did. So that's in most search-heavy applications. You have a lot of search requests. You have a lot of definitions of searches. So you can separate them and deconstruct them the same way you deconstruct your code in general. Another good thing about blocks is that people are not forced to use this declarative style, because what you're doing is just taking the block in the initializer, and if it's there, you build an object. If it's not there, you can still build in an imperative way a search definition. So that's kind of nice. That's what most people love about Tyre. It's very expressive. It allows you to express queries nicely. But there are problems. A lot of them. It's all nice, but the major mistake I did, and I consider it an inevitable mistake, was that I was focusing on the top-level DSL, because that's what I needed. I haven't created the gem just out of the blue or for academic purposes. We needed that at my contract. So I needed certain kind of behavior, and obviously I abstracted it a bit and generalized it a bit. But still, the main focus was on higher levels. That's bad, because the immediate consequence, for instance, is that settings for the library, the Tyre configure block, is class level based. So in one code base, you can't connect two Elasticsearch clusters to connect to it. That's really, really bad. Also, there's inconsistency in accessing the results. Some things you access with methods, and you have this nice DSL, but then there's a straight line, and you access it as hashes. That's again something where I didn't have enough energy to go the long mile, because I was focusing on high level. And obviously there's not enough abstraction in all those layers and all those concerns the library should have. There's a very nice example which you can look up at the internet, and a very nice discussion with David Dumery from Adobe, because he didn't like that to access variables from outer scope, when you go across a scope gate, like a meta definition or module or whatever, you have to use the blocks with argument syntax. Like Tyre search do query, query do whatever, and then, it falls down like this. And that's just, the way it's designed. As it happens, Sunspot, the best library for Solr search engine, does a lot of clever tricks to, not force you into this syntax, and allows you to use the reasonably nicer and more beautiful syntax. But then, as a deliberate designer and maintainer, you have to have opinion on that. And it's very hard. Because you know that, yes, it's nicer, but it also increases complexity of the gem. So inevitably, people will be more confused. When there are stack traces or something like that, it's harder to look up where things went wrong. So in the end, I think this is a reasonable trade-off. Like, okay, it's not as nice, but it's more transparent. But, mileage differ between people. And that's something I would like to say about the GitHub revolution, which happened in open source. From my perspective, it's great and it's awesome. You get lots of contributions, but the problem is you get less feedback and less context. Many contributors just focus on a specific task or thing they need to do. They just do it, and that's it. Send you a pull request. You have no context. You don't know these people, and everything is better when it's being discussed. So people maybe lack the focus on a bigger picture, on the context of the code base. And that's very hard for you as a maintainer, because almost anything needs to be in some way polished, amended, rewritten. So you're doing a lot of curation, not as much development. But what in my experience is like the worst part of this revolution is that people are very willing to code. Like they threw a lot of code at me, but they are shy to talk. They are afraid to talk, to get discussion running, to get context. And that's actually the biggest problem I had with the Git workflow. When we talk about problems and the gem has a very sophisticated Ruby on Rails integration. It's in the screencast. You can generate a fully working Rails application with search baked in, with data seeded. It even downloads Elasticsearch, and runs it if you don't have it running. So everything is done for you. That's cool, because it's very easy for people to start. You just run a single command, and chances are you end up with a Git repository, with a fully working application with this technology. That's cool. The tie results item is a wrapper for results. And it's fully compatible with Rails view helpers and URL helpers and all these parts of the ecosystem. Active model, every ORM or ODM or OHM, whatever out there, is compatible with Tire and then Elasticsearch. That's, again, nice. And it speaks volumes about the wise decision to decompose Rails into these modules. Because active model is just, a part of active record which you can tear out and use as OXM layer. The gem also has a rake task for importing all your data from relational database into the search index, etc., etc. But there are, again, problems. The immediate problem is that there is no proper separation of concerns and layers, as I said. You do require tire, everything is in, everything is being pulled in. That's a very bad decision. But then again, remember, usually you're starting a library in a 200 lines of code, in a gist, and then it grows. So it's in part inevitable. People expect everything to be as easy as the first step, They generate a Rails application and import stuff, and wow, that's cool. But then they hit problems. And I don't have a good answer to this. Like, it's with any technology, you hit a certain spot and it gets trickier. But obviously, documentation is something which should guard against it. When I said the tie results item is a nice way how to wrap search results, because you can use them within the Rails context. It has, the other side, the darker side, because it masquerades as your models. And lots of discussions, is ensuing from that it's bad and you should be delegating, and you don't have the object you would be delegating to because you don't have the models coming out of the database. Again, it's very tricky to strike the proper balance. And in my opinion, what's really bad is that people expect active record to be the dominant persistence layer. Like, that's it. And you tell them, no, listen, there's Mongoid and MongoMapper and all sorts of other persistence libraries. No, they don't listen. They want you to use specific active record features. So the gem is at a crossroads, basically. And obviously, the first thing which needs to be done is to split it into multiple layers. Start with the low level, just abstracting HTTP, abstracting the JSON access, the raw API for Elasticsearch, and then build on top of that, not the other way around. But still, it's something I consider you do exposed after the fact, because I certainly wouldn't have that much experience if I started the gem like this. So, go figure. In this talk, I would like to walk you through the steps needed to put some application on Elasticsearch, like to use it for searching in a real application. The example application will be RubyGems, which probably most of you know it. During the summer, I did a pull request which brings integration of Tire and Elasticsearch into RubyGems. It's freely available. When I upload the slides, it will be clickable. It's issue number 455, so you can look it up if you want. Right now, RubyGems use this for search. They use a SQL-like query, with person signs and massaging the columns, to tokenize it in a way. And it's not good. It's certainly not performant. They are not happy with it. The search is a really painful spot for RubyGems. So when you look up the issue, there's a couple of commits which we can go through, and that's what I do right now. If I can make it happen, let's mirror this place, and yeah, it's here. Cool. So can you see that? Is it okay? These are the commits. Obviously, there's a lot of stuff in there. Let's go piece by piece, highlighting the most important things. So, first of all, bringing a gem into the code base is reasonably simple. You require Tire, and that's it. You do bundle install. But boom, the next thing you need to do is fix tests, because the application tests fail because webmock disables all network access. So you need to fix it and put the disabling to a completely different place. Then we need to do even more house cleaning. We need to be sure that factory girl, which is used as a fixture replacement, triggers touch for your models, because we will be using this touch callback, this touch event, to index our data into the search index upon saves when a gem is created or gem version is created, updated, etc. So this is still housekeeping. And now we can add the simplest, elementary search possible. With Tire, it's very easy. You just include the modules like the search support and the callbacks, which will be indexing the data into Elasticsearch. And as we saw previously, we trigger the touch callback. So after create and after touch, we will update the index. That's similar to Sphinx and Solr and every other external search engine out there. And then we define a mapping for the model. A mapping is a way how to tell Elasticsearch how to interpret your data. Like you have a field called indexit, and Elasticsearch understands JSON. So if it's true and false in the JSON, it will infer the type. But obviously, it's better be explicit in this situation. And we will use toIndexJSON method to actually serialize our models into the format Elasticsearch understands. You can see we do multi-JSON dump, name, index it, etc., etc. This is a bad thing, by the way. This is another mistake I did, and I'll explain it later when we fix this mistake. Obviously, we again need to trigger the touch and fix some kind of stuff, fix some kind of problems in the test suite. Again, you can see how the integration is always around the existing code base, fixing stuff, so the tests are green and we can continue. Not a big lump of commit. So right now, when we have the support in, and I forgot, you can import your data. This is the rake task I was talking about. You just run this, and it will get the data from your database, put it in Elasticsearch. So we have the data in, and then we can replace this search implemented via SQL query with Elasticsearch one. So we do exactly the same thing they did in SQL. We issue a query asterisk, something asterisk, which is like prefix and suffix match, and index true, so only index gems are bringing in the search results. And again, we have to fix some stuff in the code base. It's still the same. We use index prefix support from Tire to separate indices in development and test, so it's not deleted on every test. And we use this RubyGem Tire index refresh to refresh the index before each step of the test. Either Cucumber, not Cucumber yet. Before search, we do the refresh. And before every test in the setup, again, we trigger the refresh. So the problem is that, and I'm sorry, I forgot this, one test will fail in this step because the beer laser query will not match a gem called beer_laser. We need to fix that. Tokenization is the process where the search engine takes your text and splits it into tokens, into discrete entities, which are then used for searching. So as it happens, we can reuse the code base because there is a regex pattern for this tokenization already there. So we can use a pattern type of analyzer of Elasticsearch, which is a regex regular expression pattern analyzer, which will split the tokens as we need them. And important thing is that we have to prefix the query with the field name, because only then can Elasticsearch match the analyzer for the name field and the query which are you putting in. Otherwise, we will be searching in the magical all field, which Elasticsearch does automatically by meshing together all the text in your JSON document. Most people, by the way, who come into problems hit this one problem, that they properly set up analyzers, but then they search in different fields. What's the answer for that? Better documentation, obviously. Next, we will use a different query. We will use the block syntax I showed you earlier. We will use a text query against the name field with a phrase prefix. And we will use a filter on the indexed property. And also to really mirror the behavior of the current code base one-to-one, we will sort all the results by downloads. That's what current RubyGems application does. It's not ideal. We'll come to that in short, but we will do it so it's same. As you see, we need to again, declare that we want to index this property and we want to index it as integer. And we will add Cucumber scenarios just for this case. Again, it's very important to keep the steps separate and to keep the test suite green. But that's not ideal, because when there are two RubyGems with the same number of downloads, then the sorting is like random. Basically, what you want, you can improve on this feature by sorting by downloads. Okay, let's do it if it's already there, but then sort by names. So you can very easily sort by multiple properties in Elasticsearch, so we will do that. And you can see we will use another very good feature of Elasticsearch called multi-field. Multi-field means that you have a single field like name, and when it comes to the analysis process, it's basically split. The process is split into two parts in this example. In the original name, and in a copy of that, which will be called name raw, and will be not analyzed. And again, let's add a Cucumber feature for that. So we are sure the behavior is okay. And this is the biggest commit, the biggest step yet. In this step, we will actually use the search engine, for something better than the behavior already there. Because obviously, a Ruby gem has lots of properties. It has, apart from name and downloads, version, authors, summary, description, lots of stuff which we created and stuff like that, which we can search. So in the comments there are links to discussion on previous implementation of search for Ruby gems, which you can read. It's very interesting. Previously, Solar was suggested, and Picky by Florian Hanke was suggested. So basically, we add a lot of stuff here. We index downloads and index it, that's already there, but also summary with English analyzer, and you can see you can say as something. In this case, a proc, a procedure, which will get versions and the most recent version and try to get the summary. There's lots of inconsistencies in the Ruby gems data, by the way. Not all gems have proper version and versions, and version doesn't have name, and you have to be very defensive, by the way, when you code in the Ruby gems code. You can see the try is everywhere, because you're not really sure if it's there or not. And we can then delete the toIndex JSON implementation. And that's what I said. I did a big mistake, to actually offering people to just implement this method, to serialize your model. Because that was very easy for me. That's a very easy answer from me on IRC and GitHub issues. Hey, man, just do this, Okay, serialize it into JSON. But then you have a split between the mapping definition and the serialization definition, and that's very bad. So what I try to do right now is to teach people to use the mapping block for not only the mapping definition, but also the serialization definition. So let's go further. We can obviously now search a lot of stuff at rubygems.org. There is a very small application I did at Heroku. At Heroku, when you don't hit it, it sleeps. So let's wait until it wakes up. But right now, we can do a clever trick, because we can search with the same query in two ways, with a Boolean query. We can search for a phrase prefix, boosting that kind of match very highly. So when there is a good match on name, we will boost that really high. It's useless, remember, because we're sorting on downloads. But this is just a preparation for a better implementation. So we can, even in this code base, do it better and then unbreak it. And obviously, we can use the Lucene query syntax, which is a very powerful syntax definition. At the example side, there are tips. So you can, for instance, search for gems which depend on reg, like their dependency is on reg, or which use reg in some way or other, maybe even in a test suite. Obviously, you can search for names. You can search for date ranges and stuff like that. So we'll see if that will come to rubygems.org. The team is certainly keen to integrate it, but at least it's a usable example for our talk. So if you're interested, go over the commits, because you will see a lot more Cucumber scenarios, and a lot more integration like that. We're running out of time, so I'm sorry. If there are questions, please shoot them. Otherwise, I will be in the hallways. Do ask me. But do we have time for questions?
About 1 minute.
So, short question?
When it will be merged to RubyGems?
Sorry?
When it will be merged to RubyGems.org? Do you have some private info? Because on the pull request, there's 2 months of nothing. So
yeah.
I would like to...
I'm in contact with the RubyGems guys, but the problem is they're understaffed. As it happens, even Phoenix, the Ruby News guy, is the main ops for RubyGems org, and you can imagine how overloaded he is. So I don't know.
Anyone that wants to be a RubyGems ops maintainer, please contact Evan.
Yeah, absolutely. Give a helping hand. So thank you.